Hello everyone, this is Sindhu. I hope you are doing well. In today's video, we will cover what is a solid principle. So it's very important in .NET interview. So let's start. So solid principle is nothing is a five principle in object oriented programming. It helps to make our code easy to read, easy to test and easy to maintain and flexible for changes and reusable. You can think like that you are making a five rules for a good house construction. If you can follow these rules, your software will be strong, safe and long lasting. Like that way in software, if you can make follow these rules, your code is easy to read, easy to test and easy to maintain and easily extendable and reusable. First one is a single responsibility principle. It means a class have only one reason to change. For example, you are making a class for an employee. So in employee class have only the details of the employee and one reason to change and only one responsibility. For example, you are going any restaurant, so here chef works only, cooks only food, waiter only serves food and cashier handles the bills. Every person have only one responsibility and one reason to change. The person focus only on one job. Here is the example where it's not follow the single responsibility principle, because in which we can make a employee class and in which we can one class have only multiple responsibility: report generate, email, code and database. Here it also add the employees and generate reports and send email. So this example is not follow single responsibility principle. Here here you can see, here we can follow the single responsibility principle. Every class have only one responsibility, one reason to change: employee only add employees, report only generate reports and email only send emails. One class, one job, one responsibility and one reason to change. Second one is the open close principle. A classes should be open for extension but closed for modification, in which we can use interfaces, so we can easily extend that interfaces method without changing the previous one. For example, here you can see, here this example not follow the open close principle. You can see here we can make this interface I payment and here we can make a method void pay. So here we can inherit, we use the same interface I payment. So here we can use for the credit card payment and here same method we can use the UPI payment. For a credit card logic we can put here UPI logic. So in which we can add a class without changing the old code. We can if we want to extend this interface, so we can easily extend without changing this method. So this is the open close principle. Next one is the Liskov substitution principle. It means a class should be must be replaceable by its parent class without breaking the program. It means a drive class object must be able to replace the object of the parent class. For example, I can explain you here. This example not follow the Liskov substitution principle because it makes a word class and in which we use a virtual void fly this method, and here we inherit this method it can't fly, so it forcefully have to implement this method, so it does not follow the Liskov substitution principle. Here we can follow the Liskov substitution principle. We use a public abstract class word and flying word we inherit, and here we can add here flying logic. In ostrich we not fly method behaves correctly. So subclasses behave correctly when it inherited, and when we used it, it means it not a force to implement that method, because here you can see in this example a word we only here we can also explain added this method like public virtual void fly, but it here this ostrich class not fly, so it forcefully implement ostrich break the rules parent promise or words can fly. So in a Liskov substitution principle is simple: the drive class object must be replaced the object of the base class. And the next one is interface segregation principle, in which we don't make a too much big interface that is forced to inherit. And for example, we can make this interface machine. In here we can put a print, scan and vex, but we only, if we want, only need this method. So we also explain here. You can see here we inherit I machine, so we can use, we only want this, but in which we add the 3 1. So it help it this example not follow the interface segregation principle. And this is an example of a interface segregation principle where we can follow interface segregation. Every interface we can divide the interface in smaller one. And here you can see I printer only for print, scanner for scan, we easily inherit, and clients only implement that interface that we want. And the last one is the interdependency inversion principle. It's a very important principle. It helps to both should be depend on the abstraction, but it means I can explain you simple way. For example, you are making any controller, rather than making all the logic, like you can make all the apis and get data and post data, all the details making in controller, rather than you can use the interface services, and you can inject that services with the help of constructor, rather than making all the services in the controller. So this is a very important dependency inversion or dependency injection, you can say. For example, here we can make this I keyword, and here we can inherit, this is the interface, this is this method we can inherit here. And in, you can say, here is the controller, here we can inherit, we can inject this method with the help of constructor. Computer can how work with any keyword, so we can here inject with the help of constructor. So this is the example of a dependency injection. I hope this video will be helpful for you. Thanks for watching. Bye bye.